Hello, Stat 200, and welcome to Lesson 9, Hypothesis Testing Part 2. Last week, you learned how to conduct a single sample proportion and single sample mean test using randomization methods. This week, we're going to learn about some more traditional methods that use the binomial distribution or Z or T distributions. Let's start with a quick review. Hypothesis testing is a method for testing the likelihood that an observed sample came from a population with a given parameter. This chart is in your online notes. It's similar to the chart that you saw in Lesson 7 when you learned about confidence intervals. This week, for one proportion test, we're going to learn how to use the Z distribution in the normal approximation method or the binomial distribution in the exact method. When testing one sample mean, your notes describe how to use the Z distribution, but we're going to be focusing on the T distribution this week. The methods for using the Z and the T distribution are very similar. In real life, the majority of the time, you're going to be using the T distribution. These are the key topics that you'll see this week. Let's start by looking at the 5-step hypothesis testing procedure. The 5-step procedure is going to be the same for all of the hypothesis tests that you do in the remaining lessons in this course. Step 1 is to check assumptions and write hypotheses. Step 2, calculate appropriate test statistic. Step 3, determine the p-value. Step 4, make a decision. And step 5, state a real-world conclusion. We'll start by looking at an example for conducting a hypothesis test for a proportion. There are two different approaches that you can use to conduct this type of test. Again, we need to check if n times p and n times 1 minus p are both at least 10. If they are both at least 10, then we're going to use the normal approximation method. Under this method, the sampling distribution is approximated by a Z distribution. If n times p or n times 1 minus p is less than 10, then we're going to approximate the sampling distribution using a binomial distribution. Minitab Express will call this the exact method. Again, the exact method uses a binomial distribution to approximate the sampling distribution. The normal approximation method uses a normal distribution to approximate the sampling distribution. If n times p and n times 1 minus p are both at least 10, you should use the normal approximation method. This is what's preferred in the field. Why? Because this is the point at which the binomial distribution becomes approximately normal. Here, we have a binomial distribution plot where n equals 20 and p equals 0.5. In this case, n times p and n times 1 minus p are both equal to 10. We can see that this distribution plot is approximately normal. Let's look at an example. A random sample of 30 people who have a group fitness membership at one gym were randomly selected. They were called and asked, would you attend Zumba classes if they were offered? Gym management wants to know if more than 20% of members would be interested in attending. In the sample of 30, 10 said that they would attend Zumba classes if they were offered. From this scenario, we know that n equals 30, x, or the number of successes, equals 10, p sub o, or the proportion that we're testing, the proportion that will be in the null hypothesis, is 0.20, and p hat, our sample proportion, is 10 over 30, which equals 0.333. Step 1, we need to check assumptions and write hypotheses. This is when we're going to decide if we're going to use the normal approximation method or the exact method. The variable of interest is whether or not an individual would attend a Zumba class. This is a yes-no response, so we have a categorical variable. We are testing one proportion. N times p sub o equals 30 times 0.20, which equals 6. This is not at least 10, So we cannot use the normal approximation method. We need to use the exact method. The exact method constructs the sampling distribution using a binomial distribution plot. Next, we need to write our hypotheses. The gym management wants to know if the population proportion is greater than 0.20. This is our alternative hypothesis. The null hypothesis is that the population proportion is equal to 0.20 because the null hypothesis must always contain the equality. We can use the information that we have to construct the sampling distribution. In Minitab Express, I constructed a probability distribution plot for a binomial variable where n equals 30 and p equals 0.2. This is essentially our sampling distribution. We could use Minitab Express to find the proportion on this distribution that is greater than our observed sample proportion of 0.333. In other words, the area where x equals 10 or higher, which would be this area here. But Minitab Express will compute this value for us if we conduct a one sample proportion test. So I'm going to go over to Minitab Express now to conduct that test. This is a one sample proportion test. We have summarized data. 10 out of 30 said yes that they would attend. We're conducting a hypothesis test now, so we need to check this box, and we tell Minitab Express our hypothesized proportion value of 0.20. Again, this is the value that was in our hypotheses. Under options, the default is to do a two-tailed test, but what we have here is a right-tailed test. Recall our alternative hypothesis was whether p is greater than 0.20. The default confidence level is 95. A 95% confidence level corresponds to an alpha level of 0.05, which is the standard alpha level. It's what we use unless we're given information otherwise. And the default is the exact method. We need to use the exact method in this case because n times p was less than 10. When we click OK, this is the output that we're going to get. We have our sample proportion, we have our hypotheses, and we have our p-value. Note that when you're using the exact method, you're not going to be given a test statistic. This is different from the normal approximation method or any of the tests for a mean that we're going to see later. Our p-value here is 0.0611. Now that we have our p-value, we can continue on to steps 4 and 5. Step 4 is to make a decision. This is where we're going to compare our p-value to our alpha level. Unless otherwise stated, we're going to use a standard alpha level of 0.05. Because our p-value is greater than 0.05, our decision is to fail to reject the null hypothesis. In step 5, we state a real-world conclusion. This is where we should go back to the original scenario to answer that research question. There is not evidence to state that the proportion of all group fitness members who would attend Zumba is greater than 20%. So we do not have evidence that the population proportion is greater than 0.20. These results would be said to be not statistically significant. Let's look at another example. Here's our research question. Are more than half of registered voters in favor of a proposed immigration law? A simple random sample of 100 registered voters were called and surveyed. In that sample, 56 said that they were in favor of the proposed immigration law. From this scenario, we know that n equals 10, x equals 56, p sub o equals 0.50, and p hat equals 0.56. Step 1, check assumptions and write hypotheses. There was a yes/no response, so we have a categorical variable. We are testing one sample proportion. N times p sub o equals 50, and n times 1 minus p sub o also equals 50. Because both of these values are at least 10, we should use the normal approximation method. This means that our sampling distribution is going to be assumed to be normal, and that is the distribution that we're going to use to find our p-value. Before we compute our test statistic, we need to write our hypotheses. Recall, our research question was whether or not more than half were in favor. So p is greater than 0.50 will be our alternative hypothesis. The null hypothesis is p equals 0.50 because the null hypothesis must contain the equality. Step 2, calculate the appropriate test statistic. In your online notes this week, you'll see how you can compute this by hand. For now, let's go to Minitab Express. It's much more efficient to use Minitab Express to complete steps 2 and 3 than it is to do these by hand. Again, in Minitab Express, we're conducting a one-sample inference proportion test. We have summarized data, X with the number of events, the number of successes was 56 out of 100. We're performing a hypothesis test against the hypothesized value of 0.50. We had a right-tailed test because we wanted to know if the population proportion was greater than 0.50. We'll use the default confidence level. And n times p sub o and n times 1 minus p sub o were both large, at least 10, so we're going to use the normal approximation method. When we click OK, we now have our test statistic, which is the z-value. So for step 2, z equals 1.20, and our p-value, so for step 3, p equals 0.1151. Step 4 is to make a decision. This is where we're going to compare our p-value to our alpha level. Our p-value was 0.115, which is greater than 0.05. We're going to fail to reject the null hypothesis. And step 5, state a real-world conclusion. There is not evidence to state that more than half of all registered voters are in favor of this proposed law. Now let's move on to hypothesis testing for a mean. Your online notes are going to show you how to conduct a one-sample mean test using the z-distribution or the t-distribution. The majority of the time in real life, you're going to be using the t-distribution. So we're going to go over an example of that right now. Last week, you learned how to use randomization methods. In real life, randomization methods are only used in special cases when the sample size is very small, and if we don't have any information or if we know that the population is not normally distributed. Most of the time, you're going to be seeing a one-sample mean t-test. Let's look at an example. Here's our research question. At one student-run cafe, is the mean number of muffins sold each day greater than 5? We're going to use the cafedata.mtw file available on Canvas or the Journal of Statistics Education's data archives found at the link below. Step 1 is to check assumptions and write hypotheses. The data are quantitative. We're looking at the number of muffins sold per day. So we are testing the mean from one sample. The sample size is large. It's greater than 30, which we'll see in a second when I go to Minitab Express. So we can use the t-distribution method. Our research question was whether the mean number of muffins sold per day was greater than 5. This is our alternative hypothesis. The null hypothesis is that the mean number of muffins sold per day is equal to 5, because the null hypothesis must always contain the equality. Let's go to Minitab Express to calculate the appropriate test statistic. Here we have the CAFE dataset in Minitab Express. We can see that the sample size is 48. Because the sample size is large, it's greater than or equal to 30, we're going to use the t-distribution to approximate our sampling distribution. We'll go to statistics, one sample inference, and at this point we do need to choose between t and z. We do not have any information about the shape of the population. We do not have the population standard deviation. So we're not going to use z in this case. We're going to use t. We want to know if the number of muffins sold is greater than 5. Under options, we'll need to change this to a right-tailed test because we want to know if the population mean is greater than 5. When we click OK, we'll get our descriptive statistics, so our sample mean, sample standard deviation, standard error. Minitab Express will also give us our hypotheses, so we can confirm that the alternative hypothesis here matches the alternative hypothesis that we wrote in step 1. And then finally, step 2 and step 3 of our 5-step procedure. Step 2 is that the t-test statistic is 1.22. The p-value is 0.1148. So from Minitab Express, we were able to complete steps 2 and 3. There are instructions in your online notes this week that go over how to compute the test statistic by hand. In general, you just need to know that the test statistic is always going to be a ratio of the difference between your sample statistic and the hypothesized value divided by the standard error. Step 4 is to make a decision. P is greater than 0.05, so we fail to reject the null hypothesis. There is not evidence that the number of muffins sold each day is greater than 5. We've gone over 3 different examples of using the 5-step hypothesis testing procedure here. There are more examples in your online notes. You should work through these examples as well as the Wiley Plus homework questions until you feel comfortable using these 5 steps, because we're going to be using these same 5 steps next week when we look at comparing 2 groups, and in the following weeks when we look at the chi-square test of independence, regression, and correlation. So the 5 steps will always be the same. Before you begin looking through the Lesson 9 online notes and trying the homework, there are a few topics from Lesson 8 that I want you to review. First, the relationship between confidence intervals and hypothesis testing. The methods that you used to construct confidence intervals using the t and z distributions are going to be similar to the methods that you're going to use this week in hypothesis testing. The meaning of a p-value. This is also very important. The meaning of a p-value has not changed since last week. A p-value will always be the probability of obtaining a sample as extreme or more extreme than the one that you observed, given that the null hypothesis is true. Type 1 and Type 2 errors. These will also continue to have the same definitions from here on out. And finally, practical versus statistical significance. You'll see more of this next week when we're comparing 2 groups, but in addition to looking at statistical significance, you should also be taking into account practical significance. So if results are statistically significant, that means that there's evidence that the null hypothesis is not true and that there is some difference in the population. It does not tell you, however, if that difference is meaningful. In order to determine if the difference is meaningful, you have to consider practical significance as well. This concludes the Lesson 9 overview video. As always, if you have any questions as you're working through the online notes or any of the assignments this week, please post them to the Lesson 9 discussion board in Canvas.